Okay, stop.
Yeah, stop it.
Don't step in front.
So, we are group number 6. And my name is Valentin, and that's Olivia, Leila, Ariane, and Joanna. We decided to see what happens when you drop Mentos into Diet Coke. We actually got a huge jet, as you might know, and we decided to calculate the pressure that forms around the walls of the bottle and makes the jet go up. So basically, we put a chair in front of a scale from about 0 to 1.80 meters. Then we placed the 2-liter bottle on the chair, and we dropped different amount of Mentos in the bottle, varying from 1 to 5. We repeated each amount twice. So, and we filmed everything, as you can see, and then we measured height and time in video point. And our hypothesis was that the pressure increases with the amount of Mentos. Yeah. This is our highest jet.
We did measure the pressure that was formed in the bottle. And to do this, we used this formula, and I'm supposed to show you how we got it. So the formula we used was pressure equals mass times the square root out of 2 times gravity times height divided by time times area, where the mass is the mass of both Coke and Mentos. 2 times g will be a constant, since it's 2 times the gravity force. H is the height, which we got from video point. T is the time, which we also got from video point, and that will be the time it took for the jet to start until it got to the peak, like the top height. And A is the area of, the opening of the bottle. So, to get this formula, since we knew the mass, we could get the height and the time. The only problem for us, sorry, I'm not going to start there yet. The actual formula for pressure is P equals force divided by area. In here, as I said before, we already knew the area. So we needed to find the force, and to find the force, we could take momentum, which is mass times velocity, and divide that by time. And as I said before, we knew the time, we knew the mass, we needed to know the velocity. So we used the laws of motion, which is the kinetic energy equals the potential energy, which is mass times velocity squared divided by 2 equals mass times gravity times height. So as you see here, we can cross mass out on both sides, which leaves us with velocity squared divided by 2 equals gh. And here we could get velocity squared. Can everybody see it, by the way? Yeah. Okay, good. Velocity squared equals 2gh, which left us with velocity equals square root out of 2gh. So now we have the velocity, and we have the mass, and we have the time. So to get the force, as I said before, it was the mass times the velocity, which we got from this formula, and then divided by time. So this is the force, but then it was divided by area as well. So we took this divided by area, which leaves us with this equation over here. I'm very sorry that it's so blurry, everything. But that's how we got that. And should I show an example of that too? Okay. You have one of,
It's okay.
oh. So, I am going to take an example from the depth that we just saw. And the mass of that, it was 3 Mentos that we used. And the mass was 1.9229 kilos. And then we had the constant, which was 19.62. And then there was the height, which is 2.01 meters. We then divide this by the time, which was also 2.01, and times the constant, which was the area, which was 4.52389 centimeters squared, and this equaled 1.37799. Correct? And we narrow this down to 4 significant figures, so this equals approximately 1.378 Pascal. And that's the formula we used. And now it's Leila's turn.
As we said before, we are group number 6. And this graph over here made by Excel, we took it and we took it by measuring the mass and the pressure. As we can see, the mass affects the pressure. And this actually proves our hypothesis, which was said before, I think, that the more the mass, the higher the pressure, as you can clearly see.
Okay, and I'm going to talk a bit about the things that affected our experiment, or things that might have affected our experiment, such as variables that we weren't able to control. And the first variable is weather, or to be a bit more specific, wind. And we try to shield our experiment with a screen by positioning the screen in front of or in the direction the wind was blowing. But still, the experiment could still have been affected by wind coming from the side. And so we could have improved this by having 2 more screens, 2 more rigid screens that were placed on both sides of the first screen. And that could have enhanced the shielding effect. And the second variable is temperature. And we weren't really able to keep all of the bottles at the same temperature. And the ones we started with were colder than the ones we used later on. And this could have easily been fixed by having a container with a constant temperature, and then putting the bottles in that container. And the third one was the dropping system. We weren't able to drop all of the Mentos in at the same time. And this could have also been fixed by aligning the pieces of Mentos vertically with the help of a string or some other mechanism. And the fourth one was that we had to use, first we started to use small bottles, but we quickly realized that they weren't really useful because of the fact that the height of the jet that was produced was really short, approximately like 2 decimeters. So therefore we switched to the 2-liter bottles. And as a conclusion, the results from our experiment confirm our hypothesis.
So yeah, we just want to say, if you believe in a bright future, vote 6.